So we're starting with the vertical members because that's actually the easiest. We don't have to do any list sorting. And the way we're going to do it is we want to make a list of all the bottom chords, a list of all the top chords, and then create lines between the starts and end points, and making sure that those two lists line up perfectly with each other. So we're going to use line by start and end point again. Let's see if we can find that in geometry. Curve, line, start point and end point. All right, but obviously we have multiple start points and end points, so we have lists that we need to bring together. So I'm going to do list create, and we're going to need a list create for the start, and we're going to need a list create for the end point. And we're actually going to use two different kinds of points. We're going to use the start point and the end point of the whole line. That's part of the list. And then we're going to use all these intermediate points that we've generated with the geometry intersect. Remember, this is only going to kick out, right now it's going to kick out 5 points. And you can see they're highlighted there. It's a little hard to see because we have some other points highlighting or showing up at the same time. But these planes generate 5 points. That's why we're getting a list of 5. So we need the first one, the 5, and then the last one. So let's go ahead and do that. So we're going to bring 3 items together in our list create. Our geometry is really the center points. And then we have a start point. So if we go back over here and look at where we have a T1, which is our start point. So I'll drag that over, which is just barely in the screen. And then we have our end point, or T3. The one we don't want to bring in is the midpoint, because that's already accounted for when we divided off our chord. So now we should have 7 items. So we have the 3 or the 5 in the center and the 2 on each end. And if we go ahead now, well, we can't actually do much with it, except we can look at it as a list. And we'll notice that we've got a list of lists. And that makes the data really complicated to parse when we try to bring back it into generating a relationship with another list. So what I'm going to do is I'm going to use our flattening, and we use flattening a lot in this kind of set manipulation. But let's go ahead and see what it does for us. So I'm just going to use the flatten command, plug that list in, and now we just come up with a list of points. Now that's our top chord, and now we have to do really the same thing with our bottom chord. So I can just copy this and paste it, and then reconnect it with the proper elements. So we have this idea of we now need those points that are in the segments below, and they happen to be the ones that we've already generated back here. So if you think about this code here, the curve points at equal segments are these ones at the bottom here, and the ones that are in the geometry intersect are the ones on the top. So we're going to hook that to our middle ones, and then we know our start and end points are just L1 and L2 because we're doing the bottom chord at this point. And we flattened that already because we duplicated that over. And now we have 2 lists of lists. And hopefully, if we bring these together, we're going to end up with the vertical chords. So I hope that explained it well enough. And let's group it together. And rename this. We'll call it the vertical members. Now the next thing we need to look at are dividing these things, these chords, into segments. So we need actually the start and end of each, we need this point and then the next point after it and then a point after it. And that really comes down to doing what's called some list parsing. And it's a little bit more complicated, so we're going to pick that up in an individual clip. And that means that if I screw up the description of it, I can easily record just that clip